Welcome to all. Myself, Dr. Vishwanath Priya, Department of PNC, Rajiv Institute of Technology, Hassan. So in this video, I'm demonstrating how to design and test the full wave control rectifier using RC triggering circuit using multi-sim. So first, let us understand full wave RC triggering of SCR circuit, how it is work. Okay, so this the full wave RC triggering of SCR circuit is a method used to control the firing angle of an SCR by using an RC phase shift network. So this circuit, it provides symmetrical trigger pulses for both positive and negative off cycle of the AC input voltage, and making it suitable for full wave control applications like the lamping dimming, motor speed control, and heater. So let us observe the circuit in the screen. So why we use the RC circuit and what is the function? Okay, the RC firing circuit allows of control of firing angles over the wide range in comparison of R firing circuit compared to the R firing circuits. And this circuit contains four diodes and resistor, capacitor, and thyristors. The power to the load is controlled depending upon the firing angle of the thyristor. So whatever is in the load, so it controlled depending upon the firing angle of the thyristor. So the circuit converted the AC voltage into pulsating DC by the full wave bridge circuit, diode bridge circuits. Then the diode output voltage is allows to the SCR to be triggered on for both off cycle of the line voltage, which doubles the available power to the load. And so in this circuit, the initial voltage from which capacitor C charges is almost zero. The capacitor C is set to this is low positive voltage by the clamping action of the SCR gate. When the capacitor charges to voltage equal to VGT, so it is equal to the VGT, I will shown in the waveform, okay, to SCR triggered and rectified voltage VDS is appear across the load. So this is simple operation of this full wave RC rectifier using the SCR circuit, how this circuit is operated. Let us clear understood by using with the help of the waveforms, okay, how the sine wave from the using sine wave signals. So here sine wave signals we are using, and when it is when during the off cycle, what happened, which diode is turned on and which diode is turned off, let us discuss in the next slides. And after that, SCR is when it is SCR is triggering, everything is discussed with the help of the waveform. Let's see the waveforms. Okay, this is the waveform circuit. So now we can apply the sine signal as an input. The circuit absorbs the waveform as it is passes through the bridge circuit and appears across the thyristors. Okay, when we apply to the sine wave signals here, and the waveform as it is passes through this bridge circuit and appear across the thyristor during positive off cycle. During positive off cycle, D1 and D2 forwarded, the positive off cycle current appears at the output. Okay, so here this is the output. The positive off cycle current is appear where it is in the output side, and negative off cycle D3 and D4s are forwarded by us, and negative off cycle current is appear at the output. So to study the effect of capacitor, so now here what happened if the capacitor, what happened, okay, when it is charges and when it is discharges, we can study it based on this positive off cycle voltage and negative off cycle. So to study the effect of capacitor on triggering of the thyristor, now consider the positive off cycle. Charge the capacitor. See here, observe the waveforms. Okay, so this is voltage, diode voltage, output voltage, and thyristor voltage. So you observe the screen. So when during the positive off cycle, the charge the capacitor with upper plate positive and lower plate negative, and capacitor takes to charge. Hence, it follows the VDS graph with a small delay. See, so VC voltage, you just observe this. So it is charging when it is during the positive off cycle, the capacitor is charges with a delay, with a small delay. That is, it follows the VDC voltage. This is the VDC voltage. Okay, this is the VDC voltage. Capacitor is charging. Okay, so with a small delay, when capacitor charges to value VGT, K2, okay, when it is, we say that is VGT, this point is, we say that VGT. So VGT, which is trigger the voltage, which is trigger the voltage of the gate junction, the thyristor start to conduct it. When it is reached the VGT, then it trigger the voltage of the gate junction of the thyristor. Then the thyristor start to conductor. The capacitor start to discharge. See, this is the observe the small changes. So start to discharge. Hence, the voltage drop across the voltage drops to zero. So you just observe this, the voltage drops to zero. This is continue till it is zero reach when the next off cycles. Okay, once again the cycle will changes. Once again the capacitor is charges, discharging. Okay, capacitor is charges and discharging. So this is the get to VGT values. Okay, understood. So observe, this is the graph. Okay. Now, so the thyristor, when in blocking stance, follows the input waveform. Once the triggering into conduction, the voltage across the drops to zero. So this pattern, this dissipated in the name of VT. So in the, see, this is the pattern. So the thyristor voltage, it is a allowable voltage and drop. So observe this is okay, turn off. So this pattern dissipated in this name of VT in the waveform. So from the waveform you can observe that is okay. The input waveform is spread across the load, and thyristor. So the thyristor waveform is subtracted with the input voltage, then the load voltage is obtained as shown in the figure with the name of V naught. So when we subtracted with this thyristor voltage and the input voltage, so you got the, what is the output load voltage, that is. So this is the firing angles. This is the firing angle. So I hope you understood how this thyristor is operated, and once the here we get the diode voltage. This diode voltage is given to this thyristor for triggering purpose. Understood that? So so this is the working principle of that full wave rectifier, full wave RC triggering using ACR. So input signal is AC input signal we provided. AC voltage is applied to the RC triggering network. Each off cycle, that is positive and negative, is used to charge the capacitor through a variable resistor. So here we are using the pot resistor, variable resistor. So what is the importance of resistor? I will show in the demonstrated. Okay, when the resistor is high, then slow charging occur, and high uh, high and high. Okay. Now let us go to the demonstration. Go to the demonstration part. Okay, just a minute. And so the RC phase shift network, RC phase shift network consisting resistor and capacitor. This is a timely delay by charging the capacitor, and the voltage across the capacitor increases as it is charges. I told that the variable resistor we are using. So when resistor is high, slow charge is occurred, and high firing angle with a low output value. So this is the waveforms we obtained. So when high resistance, slow charging, high firing angles, and low output voltage. Low output voltage. Now, so when low resistance if selected, low fast charging, low firing angles, high output is obtained. I will show in the demonstration time. So triggering through the diac, when the voltage across the capacitor exceeded the break voltage of the diac, then it is discharge the capacitors. So this is will happen, and full wave operation, full wave operation. So in the off cycle, the polarities reverses, and the same process repeated with the second SCRs. Now this is the circuit I am used for the practical purpose. Observe, this is the circuits. So here transformer 240 voltage and with the frequency 60 hertz, and 4 diodes is connected in bridge fashion. The connected one use the 1N4007T diodes, resistors, variable pot. Okay, how to select this is, so just I go to place components, go to the components. Okay, in transformer, so go to the basics, so basic transformer, so select 1P1S transformer. See, so transformer, so you can connect at the source voltage like that, and register similarly same place component, and here variable register, so 1K I can select it, 1K. So capacitor, selected the capacitor, and capacitor value 10 microfarad you select it and place like that. And SCR, just you can select it for SCR. So go to component, and so you type this is type. If you are not able to find out, just you type the number 2N1599. So all family. 1 second. So this here it is. All 1599. Select. Okay. So you got thyristor also. Okay, same. Now, so after that component connections, just run the circuit. Run the circuit. So observe in the waveform. See the full wave rectified. The output is obtained. Okay. If I want to see the some yes. So you can understand better. Okay, we go for the UJT triggering circuit for controlling the full wave rectified using RC. So this is the circuits I am using. So in this method, so we understood that how the firing angles are changes, VT and load voltage, that is output voltage. The So here we once again we use it required bridge rectified, that is a bridge rectified circuit with a step down transformer, followed by the xeno diode, 1 point resistor, capacitor, SCR, and UJT. So this is the UJT. So the firing angles are varies can and varying the based on the varying the pot, varying the firing angles. Whenever gates is applied, SCR is turned on, and we can get the firing angle output across it. Well, so just observe, this is the connection. Just I am adding this um, UJT 194728 is a UJT, and the pot is once again the pot is varied with this triggering SCR circuits. So just I will show the waveform. In this circuit, we understood the clear how this varying capacitor values. Once again, yes. So I keep both 2020 scale and so blue color indicated the VT, and red color is load. Okay, just I varying the capacitor. Okay, when 50% varying, so I got the output, uh, and 0% when its resistance is low. See, this is our VT. Okay, we get the output is so when resistance is 0, observe the outputs. Okay, just I was showing my waveform. See, output are very small and VT. Just observe this. We clearly understood that. Okay. So this is the waveform we got it. Different using UJT triggering circuit for controlling the full wave rectified. So it's the waveforms. 50% and maximum. Okay. So once again the resistor value is 50% equally distributed. If it is combined, just combine this adder, you get the full output voltage. I will combine the both VT and V naught. Okay, get so maximum, because both are connected in series. This our load voltage and triode diac voltage connected in series. See, sorry. Okay. So thank you for watching the video. I hope understood that the concept of how to design and implementing the RC full wave control rectifier using RC trigger. Thank you.